Hi everyone, welcome at the second Aquasuite webinar. Today's topic is prevent blocked sewers using AI. Yeah, it's exciting to have you all here. We have people from all over the world, UK, Malaysia, India, Europe, Mexico, United Arab Emirates, and even more countries. And it's nice to see that we also have a diverse mix. So we have engineers, business developers, CTOs, directors, etc. So good to have you all here. So my name is Maha Benashir, and I'm the marketing manager at Aquasuite. And today I'll be your moderator. Some rules to keep it smooth. So the presentation will take about 50 minutes. If you have any questions, you can use the question box during the whole presentation. At the end of the presentation, we will have a Q&A where my colleagues Tom Woolley and Christoph Lubbers, who will introduce themselves briefly, will answer your questions. If we don't manage to answer all the questions, no worries. We will send an email to you after the webinar. If for any reason you have technical issues, please use the chat box in the control panel. I'll be there and try to help you as much as I can, but please bear with me, we're with a big group, so I'll try to answer as soon as possible. During the presentation, we'll have 3 polls. I will announce the questions. You'll have about 1 minute to answer the questions, and then my colleague Christoph will elaborate on the results. And at the end of the webinar, we will have a brief survey where we ask 3 questions. So it'll be nice if you guys can provide us with some feedback. So yeah, all I can say is now sit back, relax, and enjoy the presentation. So over to you, Tom.
Good afternoon, everybody. I hope you can all hear me okay. Thank you, Maha, for the introduction. As mentioned, there will be myself, Tom Woolley, with the presentation part of the webinar, and Christoph Lubbers, my colleague, will join during the presentation with feedback on the polls, but also as part of the Q&A at the end of the presentation. Just to give you a bit of background on myself and Christoph, I'm Business Development Director within Aquasuite at Royal HaskoningDHV. My background's within IoT analytics and optimization for the water sector over the last 15 years. Christoph Lubbers has been with Royal HaskoningDHV for around 12 years, I believe. And his background is with a PhD in wastewater transport. So hopefully today we can give you an informative presentation on how we think artificial intelligence can improve wastewater networks. Hopefully you can all hear me, but if you do have any technical difficulties, if you can't hear me correctly, or if the presentation doesn't come through clearly, please do put a comment into the chat box, and Maha will pick that up. But also, if you think I'm talking too quickly, please also drop something in there to say slow down, Tom, because I know at times as a native English speaker, I can talk a little bit too quickly for those of you who have English as a second or third language. Okay, so we're going to start with the first poll, and the question we've got, just to get you all awake and paying attention, is, are sewer blockages a high priority in your country? And can I ask Maha to put the poll up for us? Maha, can you launch the poll? There we go. So hopefully you can all see the 3 options on the screen. I'll hand over to Maha. You can advise on how people can enter their answers.
Yes, of course. Yeah, are sewer blockages a high priority in your country? Please select one of the answers. You will have approximately about 1 minute, and then Christoph will elaborate based on the outcomes. So we're still collecting some votes right now. All right, we'll be closing the poll right now. Okay, and I'll hand it over to Christoph. Christoph, can you, I'll share the results. Can you please elaborate on the results?
Yes, of course. We are operating in different countries in the world, and we see a difference in how people perceive this problem. There are countries that don't have any blockages, or they don't have policy on it. It's not important to them probably because it doesn't happen. But we also see countries that have lots of problems with this, and it would be interesting to understand why that is. Is that because of difference in how the sewers are designed, or is the difference in how people use the sewer system? That's always a sensitive topic, of course, but we like to understand that. In the meantime, we cannot change the sewer design easily. We can also not change the behavior of the people. So in the meantime, we can only have a good monitoring system and warning system in place so that we can have the operators act on it if blockages occur. So that's what this webinar is all about, and I think Tom can elaborate on that. Back to you.
Thank you, Christoph. Yeah, thank you very much. Okay, excellent. Thank you very much for everybody for participating. As Maha said at the start, we've got a really diverse geography of people represented on the webinar. So good to see that everybody, or most people, apart from 4%, think that sewer blockages are an important topic. So that's great. So just to give you an overview what we're going to cover during the presentation. So we're going to start off by, apologies, I think there's a slight delay on the presentation. We're going to start with an introduction and background. We're going to look at what the problem is. So sewer blockages, why do they happen? Why are they an issue? And why do they appear to be more of an issue now than they were perhaps 10, 15, 20 years ago? We're then going to look at the detail in why and how artificial intelligence and wastewater systems can work together, looking at what's needed for AI, and then in turn, what AI can provide to water and wastewater operators. A quick summary, and then we'll take any questions you've had as we go along. Just to reiterate, if you do have any questions, please do type them in the question box or in the chat box. Maha will collect them all together, and at the end, we will answer as many as we can. And if we don't have time to answer the questions, we will come back to you separately with a follow-up email with a copy of the presentation, and also a response for a chance for you to ask any questions you might have. Okay, so just to give you an idea about Royal HaskoningDHV, for those of you who aren't familiar with the company, and perhaps why we are presenting this webinar and why we think we have something to add to the debate. So as a company, we are very well established, well over 135 years old. We have projects in over 140 countries worldwide, offices in, I think, over 20 or 30. I lost count slightly. We're about 6,000 people worldwide, so we're not huge, but we do have our very strong niches, and that's what we like to focus on. So the company aim and motto is enhancing society together. And as an independently owned company, we're a foundation. We can really put our efforts into what we think is going to improve the life of people in society, and also help our clients and our customers to become more efficient and more effective in what they do. Bit of background on Aquasuite. So I mentioned at the start that both Christoph, myself, and Maha are from the Aquasuite team. There's lots of talk at the moment about smart water and Internet of Things and big data, and how all of this stuff is going to change the world for water and wastewater utilities. Machine learning and artificial intelligence isn't new. The first neural networks were developed in the 1960s, if I remember correctly. The first Aquasuite application, so the first deployment of machine learning by Royal HaskoningDHV for water, was in 1996. So the Aquasuite team, much like machine learning and AI, isn't new in water. So we actually started working with one of our clients in the Netherlands, who was a consultancy client of ours. They had a particular challenge around drinking water. So they had a big urban area, a city, and that city was fed with water from 3 different sources. And their big challenge was, how did they balance the water supply to that city while still ensuring people got enough water, but they didn't breach their abstraction limits. And that was really tough for them because they didn't know how much water people needed. And we deployed our first Aquasuite algorithm and our first deployment of machine learning in 1996 onto that city to predict how much water they would need for the next 24 hours. And Aquasuite grew from there. So the people who worked on that very first application are still in the Aquasuite team now, which is great to see. And quite quickly, we went from that first deployment of predictions, machine learning, into what we now call the virtual operator. So the ability to predict what's going to happen, but also to use that prediction to make processes more efficient and more optimized. That was the focus of our first webinar, the virtual operator. And if you do have interest in that, please get in touch and we'll be happy to share a copy of that webinar presentation with you and answer any questions you have. And quite quickly after that, so 1998, we deployed our first optimization solution for drinking water. We now optimize drinking water for around 80% of the Netherlands. So it's quite a big share of the market we have in the Netherlands. Fairly quickly after that, we moved into wastewater treatment. And then very shortly after that, we developed the first Aquasuite Narada controller. So those of you who are familiar with wastewater treatment may be aware of our Narada wastewater treatment technology. It's a type of anaerobic granular sludge. And every Narada deployment is controlled by Aquasuite. We have a predictive controller which predicts demand into the Narada wastewater treatment plant and then optimizes the processes based on that prediction. And we've got now worldwide references of probably well over 250 deployments of Aquasuite. Rather late in 2012, we realized we've got this really great prediction. We've got a really good way of predicting what will happen. And we were using that prediction to control processes based on what was going to happen. In 2012, we realized, okay, this prediction could also be used for providing insights. So it could be a method of guiding the actions of water and wastewater utilities into a more efficient mechanism based on differences between the predicted data and the actual data. And that's the basis of what we're going to talk about today, using artificial intelligence, using machine learning to decide or to recognize when things are not working correctly. One of those deployments was in 2016. We developed a solution to detect and locate leaks and bursts on drinking water. And in 2018/19, I believe, we deployed the solution we'll partly talk about today, Aquasuite Sewer, which looks at how you can use AI to locate blockages, to predict overflows and predict spills. All of the growth we had up until 2017, 2018 was entirely organic. So Aquasuite grew on the back of where we worked in consultancy and engineering. In 2018, we pivoted to the model we have now, which is more of a product solution type model, where we work directly with water utilities and with partners to supply machine learning and artificial intelligence solutions for the water and wastewater utilities. And we've scaled really quickly from 2018. We're now active across the world. We're in Singapore, we're in India, we're in parts of the UK, we're in other parts of Europe, North America. And our vision is still the same. We want to provide good digital solutions across the whole water cycle based on machine learning. That's our role. A really nice infographic which recognizes this is a piece of research done by GWI, Global Water Intelligence, and they mapped the water and the smart water market, looking at where different companies fit. And where they mapped Royal HaskoningDHV, in particular Aquasuite, was in this nice spot between data management and analysis and automation and control. And it's really nice to recognize that's our aim. So we want to be able to provide useful information on top of sensor data, and in turn, when possible, provide optimization and control strategies. And they only mapped 3 companies in this space, and we are the only ones who don't do hardware. And that's our mission. We want to be hardware agnostic. We want to use good data and provide useful information and actionable insights on anybody's sensors and equipment. And that's quite relevant to what we'll talk about today as well. Give you an idea of the companies we work with. There are many more of these, but these are a selection of some of the companies in the Netherlands and Europe and India and Asia that we work with, and it's growing all the time. So let's start by looking a little bit at the problem. So why do we think artificial intelligence is going to become more useful for wastewater networks than it has done in the past? So like it says on the screen, wastewater infrastructure is getting more and more complicated. We're seeing rapid urbanization across the world. We're seeing new housing developments. We're seeing repurposing of existing brownfield developments. We're seeing factories becoming apartments. We're seeing redevelopment. And the whole process is becoming more and more complex. We're seeing more pipes, more interconnections. And if you couple this rapid urbanization and this change of the built environment with climate change, then you find that sewer networks, gravity collection systems, are particularly vulnerable to this challenge. You've got probably the most difficult part of the water and wastewater network, because you've got the human input from people's use of drinking water and obviously passing out wastewater, coupled with a system which generally, in the majority of cases, will also collect rainwater. And that makes it really difficult to understand what is happening and what will happen. And that's why we, and I think a number of our clients and also a number of our competitors, have seen that wastewater collection systems is a particularly challenging area and particularly relevant to artificial intelligence. So it's somewhere where AI can really make a difference because it is such a difficult area to understand. The second problem we see is it's a really difficult area to understand, and you've got some really great operators out there. So water and wastewater utilities have some fantastic people who are really good at understanding what is happening in their networks. The problem is these people are getting older and they're starting to move towards retirement, and the people that are coming into these roles are not necessarily as willing or as happy to stay in the same role for 10, 15, 20 years. In the past, you would have seen people working in control centers or wastewater treatment plants or as wastewater network inspectors, and that would have been their role, and they might have done it for 20, and I know a guy who did it for 45 years. The newer generation, for a variety of reasons, are not as happy to stay in that same role for such a long period. And that presents particular challenges, because we all know that if you go to a water company, you want to know what's happening in a particular area, they'll say, oh yeah, ask Joe. Joe's been here for years. He knows everything. He knows what's going on. What happens when Joe's no longer there? That's the challenge that we think digital solutions can really pick up. There's a window of opportunity for the next probably about 5 years, to take the opportunity to download these people, to take their knowledge, take what they do and their understanding of trends and processes, and put that into software. So take what they're doing and build it into a solution like our Aquasuite platform, and be able to understand their knowledge and what they do and what they recognize from looking at trends, and put that into the software so you can replicate it. And that's the key. You can then make the system less at risk. You make it more resilient, but you also take that really good operator and you can replicate them and you can deploy them 100 times, if not more. And that gives you the real ability to maximize their knowledge and their experience across the whole of your water and wastewater systems. So looking more specifically at sewer blockages, I think we're all familiar, or most of us on this call anyway, will be familiar with pictures like this. There's a couple of images from New York, I think, and from London. This is common across well, as our poll said at the start, this is common across 96% of the countries represented here. So we see sewer blockages, and there's been lots and lots of talk about fatbergs, but not all blockages are fatbergs. Not all sewer problems will lead to huge, big fatbergs, but these big fatbergs, these big problems, and these big flooding incidents start from small issues. They start from a build-up, an accumulation of fats, oils, and greases, together with things which shouldn't be in sewers, perhaps. And these small blockages, these small build-ups of silt, of dry matter, of other items, eventually become a big problem like we see there. And to give you an example of some of the headlines that we see, or I've seen around the world, on the screen now you can see these are some examples from the UK, from Australia, and from North America. The one at the top right, which mentions Severn Trent, that's actually from my local newspaper. And as a result of the lockdown, I don't know if it was common in a lot of countries, but certainly in Europe and Australia, there was a big shortage of people being able to buy toilet paper. Because of this, people were using things that they perhaps shouldn't use for toilet roll, for toilet paper. And this meant that a lot of things were getting into sewers which weren't degradable. So things like baby wipes, newspapers, all this sort of stuff was getting into sewers. And my local water utility where I live, as it says there, attended 3,000 reports of sewer blockages in 2 weeks. And that was in the first 2 weeks or second 2 weeks of lockdown. So it's a point in time when you really don't want workers and utility workers to be going out into the community. And because of the issues around sewer flooding and blockages, it meant that there was I think it was fairly 200–300% increase in the amount of work that the water utility was having to do in the community. So it wasn't great. But also, even when in the vast majority of cases, it's not the fault of the water operator or the wastewater utility, they get blamed. So if we look at the bottom left here, this is a story again from a local newspaper in the UK where people's homes were blocked and the water utility was getting the blame for the problem. As you can clearly see, most of that issue is around rainwater. So it's not the water utility's fault. And it's usually linked to things ending up in sewers like we see in the bottom right. That's concrete. That happens quite often, that unscrupulous companies will dispose of matter in the sewers that they shouldn't do. So all of these things together become a really big problem. They become a really expensive problem for water utilities. And what we think the opportunity is for artificial intelligence is being able to couple together data, information, and prevent these small issues, these small buildups of silt or these nascent blockages becoming really big problems like we saw with the fatberg in the previous slide. And that's the opportunity. So it's taking this move towards big data, taking all this data that you can get from sewers. So if we look 10 or 15 years ago, the knowledge and the understanding of sewers and gravity collection systems wasn't great. So there weren't really a vast majority of sensors installed within the network. There might have been short-term flow surveys, there might have been short-term inspections, but there really wasn't the ability to understand what was happening in sewers on a day-to-day basis. And where we are now, certainly over the last 10 years, there's been a real build-up in the ability to see and visualize what's happening in sewers. So we've got to the point where there are a lot of sensors in sewer networks. The problem now, or the issue now, or the opportunity now, actually, is how do we use those sensors rather than to understand what has happened? How can we use those sensors to understand what will happen and how we can make a change to improve wastewater management and wastewater infrastructure based on that data that at the moment we're perhaps not making the most of? And that's kind of the vision, and this kind of oversees everything we do in Aquasuite. It's the ability to foresee what's going to happen and then actually take that prediction and make what you want to happen. So it's turning the understanding of, yeah, machine learning is telling me, I think this is going to happen, but actually how can you twist that? So rather than what's predicted to happen, how can you make it better? And that's kind of the guiding principle for us. We think that data-driven solutions will help deliver a more reliable and a more resilient water and wastewater infrastructure. And in the past, that was hampered by the fact that you couldn't get data. We're really now in a situation where you can get data. There is the opportunity to get really interesting, really reliable data in sewers and then make the most of it. The starting point of that, we think, is making predictions. So if you can get data, you can predict what's going to happen. If you've got that prediction and you can bring that together with an anticipation of what's going to happen and what might change, you can then make actions and you can essentially take what might become problems and turn them around and prevent them happening. So you can bring together data, you can bring artificial intelligence, and that allows you to tackle events and problems before they become major problems. So you can get to the situation in the sewer, but rather than getting a great big huge fatberg which might take you a month or 2 months to remove, you can actually just jet out a small blockage before it builds into a big fatberg. And that's the opportunity for artificial intelligence in sewers. And we'll talk a bit more about that after the next poll, And I'll hand across to Maha to introduce the next poll.
Yes, thanks, Tom. So our second question is, let me just launch it. How reliable do you think sewer level instruments are? Again, you can just choose one answer. So extremely reliable, somewhat reliable, or unreliable. We will give you guys about 1 minute to provide us with an answer before Christoph will elaborate on the results again. 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I hope everybody had sufficient time to answer. I will just close the poll and just share the results with you guys. Okay, Christoph, can you tell us something about this?
Yeah, I think what it shows is that people have not too much trust in the reliability of the instruments. Maybe because of experience that they have or that they get fouled and don't give the right signals anymore. Obviously, it's yeah, a reliable warning system, as Tom explained, needs a reliable measuring system. If you don't have the right measurements, it's difficult to get the right answers in, of course. And we see that in the past, we focused on the higher water levels because most of the level transmitters are located in CSOs, which means that we want to detect when a spill has occurred. But what we now see is that what we saw back then is that if you have a few centimeters of inaccuracy, it would mean a lot in the volume of the spill that you calculated. So most of the focus was on that high water levels. But what you see now is that the buildup of fatberg starts, of course, during dry weather flow. You see that water levels change a bit and get a bit higher. So we need more focus on that lower levels. And luckily what we see now is that the instruments that we see now can do both. They have a system for lower water levels and higher water levels. And if you combine those, then you could see that that we can use the accuracy of the lower water levels to feed that that fouling detection system. So it's good to see that the market is improving on those instruments, and that we could use that for the monitoring systems.
Thank you, Christoph.
Okay. Back to you, Tom.
Thank you very much. That's a really nice setup for the next part of the presentation. So we're going to look a little bit about data and inputs, which is a really central part of any artificial intelligence system. I think the polite phrase is rubbish in, rubbish out. So we need to make sure that what comes in is going to be good, so we can then in turn give good outputs. And here's an example. So this is a real life trend from one of our sensors feeding into Aquasuite. And just like Christoph said, we're starting to really see a move within the market away from cheap, poor quality sensors to IoT sensors, which have perhaps better communications and better battery life, and also low cost, but also good data. And that's the key thing. We want that good data, and this trend shows that really well. So in the period from 14th of April up until 28th of April, you can see a fairly clear diurnal pattern, and that's what you would expect in dry weather flow conditions. Now the pattern itself is a little bit flat. That reflects more that people, this is UK, people in the UK are not leaving their homes at the moment. We're in lockdown. But you can quite clearly see that sort of evening, morning, nighttime change that you would expect with dry weather flow. And that's what you need. If you can get to the point where you can clearly see patterns, as we can here, then you can use that data to actually identify problems before they become big problems. The second part of what's needed for good inputs to an artificial intelligence system is represented by the end of this trend. So you can see those two big spikes. That's the 30th of April, and it rained a lot in the UK. So on that day, it hadn't rained for around a month. We had a huge amount of rainfall, and you can actually see in this trend quite clearly that prior to that rainfall, there was a buildup of dry matter in the pipe. Big rainfall event, and the pipe cleared itself. And after that rainfall event, you can see the level in the sewer is lower. So you can see from this data, just from human interpretation, that there is the ability to pick up patterns. And that's what we're looking for in artificial intelligence. This is a typical data science curve, and it really highlights what Christoph just touched on. Up to maybe the last 1, 2, 3 years, sensors in sewers have tended to be put in to monitor combined sewer overflows, CSOs. That's what we would term descriptive analytics. It's telling the water utility what did happen. It allows them to report to the regulator to say, yeah, we spilt, apologies, but it was raining, so it's allowed. What we want to do is actually take those same sensors, those well, sometimes termed event duration monitors, take those event duration monitors and actually use them to improve what will happen. And that's prescriptive analytics. And that's the journey that artificial intelligence can take you using the same sensor. So this sensor we saw in the previous trend, that was installed as an event duration monitor. We've deployed artificial intelligence on top of that, and we've actually turned it into a tool which can help water utilities improve what will happen in their network. It becomes a prescriptive analytics tool. The second input, which is essential for artificial intelligence, is rainfall. This is a really nice image that I found on the internet from NASA. So, and it actually, although it looks good, it does highlight a fact. So in the past, rainfall data had perhaps a bad reputation. And that's partly because of the coverage of satellites and airplane surveying equipment. There's so much more ability to see from satellites what's going to happen in terms of precipitation now than there was 10, 15 years ago. Satellites are being launched all the time. And obviously, prior to the current situation, air travel was increasing, and that air travel also gives you a feed into the understanding of what will happen. So you can get something like this, and this is showing a precipitation map for the island of Guam. If we can take that understanding of what will happen in terms of rainfall, and we can use that historical data together, we start to build up a prediction of what will happen. And that's what we're getting to. So if you can look and you can clearly pick out a dry weather flow pattern, use that as a prediction for the future, you've got your rainfall. Those two together are starting to give you the ability to predict what will happen. And I'm not going to go into this in too much detail because it's not my area of expertise, but artificial neural networks are a really good way of modeling what will happen in sewers. So we've touched on human input. So that's your dry weather input. That's when people have showers, when they have baths and all the rest of it. You've also got the rainfall. You also have other factors which feed into that. So you might have manufacturing, you might have commerce, you may have festivals, you may have vacation periods. All of those inputs feed into what the level in your sewer should be. And that's why artificial neural networks, particularly, are useful for sewers, because they are really complex. You've got lots of different inputs, you've got lots of variables, you've often got fairly aging infrastructure, so it's not always the easiest to model what will happen. It's not a pressurized pipe, so drinking water, obviously it's pressurized, and there's certain characteristics which go along with that. A gravity collection system is probably one of the most difficult things to predict what will happen. And that's why we use neural networks. So we're using artificial neural networks. I think the technical term for the one we use is a quantile regression deep learning neural network, but other ones are available. These are the type of solutions that can build something like you see on the screen here, where you can see that same diurnal pattern, but you can also see the influence of rainfall, and we can start to pick out the red dots, which are the problems. And that should lead into the next poll. Maha?
Yes, thanks, Tom. So our final poll question. How are you or your clients warned that your or their system is blocked? So again, you can only select one answer. So the first one is we get phone calls from inhabitants. Second one, we measure spills at CSO. And the third one, we have a daily check of levels in the sewer. And again, 1 minute for you guys to vote. So take your time. All right, so final countdown, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I hope everybody has sufficient time to respond. Just gonna close it. And I'll just share the results. All right, Christoph, can you tell us something about this?
Yes, of course, we were hoping that 100% tick the last box. We have a daily check on levels in the sewer. But we are realistic, and we also know that the water utilities are sometimes called by the inhabitants that something happens. And obviously, you don't want to have that. What we see with the climate changing and with heavier rain intensity, there's more focus to the sewer system itself, and there's a bigger ask for a better monitoring system that can warn in advance. Because what we been talking earlier is that the focus first was on the CSI to look back on what happened. We now want to be warned by a monitoring system that something is growing. You don't want to be called by inhabitants, of course. It's embarrassing for the organization. So we need to know during dry weather flow if something is changing already. So that's what we see at the moment. Like Tom explained, if we use the old instrument that we normally use to detect CSOs, we can look at patterns. And if you would check the levels by eye, you don't see the small or the slow changing things or processes in your system. And with these machine learning models, you could see the actual levels and have this bandwidth with what is expected around it. So, and have automated warnings about that. We also talk to people that check these levels and the instrument by eye or do it manually. But for the bigger utilities where you see tens of thousands of instruments, you don't have the time to do that anymore. So these automated systems would help you do everything in the same day for all 20,000, for example, measurements. So I think that's what we are going to see in the future.
Thanks, Christoph. Yeah, thank you. So we're going to carry on the next session to look at how we can bring together all that data, that ability of neural networks to predict what's going to happen, and hopefully take actions which improve the networks. Just a reminder, if anybody does have any questions, please do drop them in the chat box or in the question box, and we'll be very happy to answer them at the end of the presentation. So if you've got AI, you've got artificial intelligence, you've got something like we just looked at, the ability to predict and decide what's going to happen, you can use that data and those inputs to take actions which will prevent sewer flooding. And that's the real key. That's the abiding takeaway from the solution. It's how can you do something with the data? How can you use AI, not for a nice dashboard, not for a good KPI or something? How can you use that to prevent problems for your customers and for water utilities customers? And as we saw in the poll there, 68% of people find out about sewer flooding incidents from their customers. That's if I'm a water customer, my house is flooded, then that's not always the way you want to find out about it. So just to look at the first example, apologies. Here's a algorithm which we've developed internally to decide whether the data from an instrument is operating in its correct range. This is what we call anomaly detection. So you can see in the image on the screen, there is a orange line, and that orange line goes along quite happily. It increases, it comes down, and so on. And you've got a blue shading around that line, and that blue shading is the output of one of our algorithms. That's giving you the acceptable operating range for that particular sensor. And it gives the utilities or the users of these instruments the ability to know whether the level in the sewer is correct. So do we have problems in the sewer, or is the sensor working correctly? As we looked at earlier in the poll, the second poll, I think it was, There has been a perception that sewer level sensors are not the most accurate in the world. And if you've got a model like this, if you've got the ability to detect the normal range of operation for the level in that particular point, then you can start to detect when your sensors fail, but also you can start to detect up or downstream blockages. And these blockages aren't necessarily going to trigger that a level alarm. You can see on the screen here, there's a black line, which is your alert level. They might not necessarily trigger that alert, but if they're left to their own devices in 2 weeks, 3 weeks, even 6 months time, that small problem becomes a big issue and may lead to sewer flooding. And here's an example of that. So here we've got the blue shaded area, and that's what the algorithm is saying the level should be in the sewer. And you've got the orange trend, which is consistently above that band. And that's an indication of maybe one or two things. It could be an indication of a silt buildup, that you've got dry matter in the pipe, or it could be an indication of an up or downstream blockage. It's unlikely to be a sensor failure in this case. And the AI is able to, and the system is able to start to categorize these issues to say whether it's an upstream blockage or it's a silt buildup. In this case, if you think back to the trend we looked at earlier, where you saw the prolonged dry period in the UK prior to the 30th of April, this is a reflection of that. So as we start to see changes in climate where we don't necessarily get that prolonged, slow rainfall that we used to get in the UK, for example, you might get short, sharp rainfall events. And what this means in these prolonged dry periods is you get a buildup of dry matter within your sewer network. And that dry matter gets flushed out. It's called the first flush with the rainfall. But that dry matter, if it goes on for too long, can cause the start of blockages and can cause the start of issues. And we can look at this type of trend and we can couple it with an event system which says, okay, yeah, it's out of band, but it's not a problem yet. You can actually start to categorize it. Okay, how far out of the band is it? How long has it been out of the operational band? And when you start to hit a critical threshold, where maybe it's 100 millimeters or 200 millimeters above the band, and it's been out for 1 week or 2 weeks, you can actually use that to trigger an action. And that's where we really do think the benefit to water utilities will come from. If you can recognize that your sewer level, your CSO level, or even just your network monitoring level is incorrect, and you can recognize that you've got a certain time period, you can get out and clear that. You can deploy a jetting team. It may be a symptom of a failing sewer further downstream. It might mean that one of your pipes has started to bow or started to break. You can get out and you can solve those problems before it becomes a blockage. And that's the real key. It's the ability to look at the data and have the data tell you. So you don't need to have someone looking at the trend all day long. I mean, we think these are nice looking graphs, but you don't need to have someone looking at it. You need the system to tell you that this site here, there is a problem. This problem is about to occur. Now is the time for you to go out and clear that blockage or clear that pipe. That's the key. If you can start to use this type of analytics coupled with a advanced alert system and advanced event detection system, you can clear the problems before they become something like this. So here's an example. This is a overflow discharge which occurred when it wasn't raining. So definitely was the result of a downstream blockage. And what happened is that it was just left, it built up, and eventually there was a spill when it wasn't raining. So that was an unconsented spill, which might result in fines or various difficulties for the owner of that particular asset. And that's the key. How can you react to that buildup of problems before this happens? Just to quickly touch on the next one, this is another algorithm we developed. What we're doing here is predicting the level in the sewer for the next 24, in this case, 48 hours. And this isn't always, there isn't always something you can do about it. So if you're predicting a high level because it rains, well, it's raining. There isn't a huge amount you can do about it. But if you have a asset, a CSO in an area of particular significance, it might be an environmental beauty spot, it might be a beach, it might be somewhere where people go swimming, and you know that in the next 48 hours we're going to spill, you can start the process of warning stakeholders. You can tell people, don't go swimming in that river, don't go walking on that marsh, because we know there is going to be a spill in the next 6 hours, for example. And you can, although you can't necessarily prevent them, you can actually help your end customers understand that something's going to happen and they can keep themselves safe. Also, if it is a particular area, you could perhaps deploy mitigating matters. You could pump it out, you could put a temporary tank in the place. There's things you could do. So what does this all mean for you? What do these AI algorithms and these actionable insights mean? It gives water and wastewater utilities a better understanding of the network. That's key. Gives them the ability to understand what will happen. And if you know what will happen, you can in turn reduce the problems which might happen. It gives you the ability to proactively warn stakeholders. You can tell people before there are problems, and you can also take actions to prevent problems. You can jet that sewer. You can deploy that temporary detention tank. You can divert the flow to a different area. And ultimately brings in this catchment-wide thinking, this vision that what you collect, what you transport, what you pump, and what you treat, and ultimately what you process is all linked. And that's the wider picture. It's not just looking at catchment solutions in terms of collection, what we've looked at. Everything you collect feeds into your pumping stations. And if you have a really good understanding of what you're collecting, you'll have a better understanding of what you're pumping and what you're going to treat. And you can treat the whole system as one constituent whole. You can make everything work better because you know exactly what's coming in and you know where it will be at what time. You can really get towards this complete systems thinking, this catchment process of managing everything together. Slightly went over time, so I'll just cover this a little bit quicker than I was planning. So here's a nice comment from one company we've worked with. They're a specialist provider to wastewater utilities in the UK and Europe, and they're using some of the analytics we've just looked at to provide advanced warning to their clients of potential issues. And that brings us on to the question and answer. So I'll hand over to Maha, who has hopefully collated the questions, and she's going to ask Christoph and perhaps me some of the questions you guys have submitted. Thank you very much for listening.
Thank you, Tom. Yes, so we have a few questions. Let me just start with the first one. We have a question from Pravasant from United Arab Emirates, and his question is, do you have any statistic how much countries spend for sewer network maintenance? I think that's a question for you, Christoph.
So I didn't get that. How much money is spent on sewer maintenance?
No, sorry. Yeah, how much countries spend for sewer network maintenance, if we have any statistics?
I think not off the top of my head. Sorry.
No, I think it varies by country. So in the UK, we're spending more and more. It's becoming a bigger and bigger high priority. So in the UK, I think it's the second highest priority for customers of water. Sewer flooding, so it becomes more and more important for customers, and then the regulator forces the water utilities to invest more in it. But it does vary. I think country to country, it varies on the size of the collection systems. Anything between, I would say, between 5% and maybe 30%, perhaps. All
right, thanks, Tom, for the answer. We have a question from Fadi. Said, good day, thanks for this presentation. What are the types of sensors that we're talking about? A question for you, Tom?
Yeah, I'll pick that one up. So the sensors that we've used within Aquasuite Sewer, we've used ultrasonics. So the ability to measure the level using a reflective sound wave. We've used pressure sensors. We've used radar sensors. We've used Doppler sensors. I can't think, there's probably other ones as well, float switches. The key thing for us is we want good data. And I think like Christoph said earlier, there isn't necessarily one size fits all. So you can't necessarily say we want ultrasonics on every installation. Each problem has a different type of sensor which fits it, I think. And we're starting to see sensors coming onto the market which can perhaps combine more than one type of measuring instrument and give really good data at low levels, but also at high levels as well. And that's perhaps the key.
Yeah, the good thing about these models is that they can use any signal that's available that says something about the process. For example, there are instruments that have a combination of velocity and depth, or velocity and level. And what you see is that there's a buildup of silt. The relation between velocity and level starts to move. So if we put that into a model, they could also show depth anomaly. So for example, if there's silt on top of the instrument, it still recognizes the pressure, so it still recognizes the level, but the velocity goes to 0. So all these sensors that come from the sewer can be combined into a model, and that says something about the process. So when it reacts differently from the normal, we can detect it and warn the client.
Thank you, Christophe and Tom. Okay, I see we have a few more questions. This one for you, Christophe. What are the specifications for sensors design of new sewers in cities?
The specifications, probably a certain amount of resolution. So I think you need to be able to measure within a centimeter or something to recognize the differences in water level. We see that especially to recognize slow buildup of silt, you need the low water levels. That needs to be accurate. I think that's one of the biggest one. And maybe for time resolution, I think if we are around the minute value, that would be okay. Obviously, put it somewhere where it doesn't fall too much, but that's more the application.
Thanks, Christophe. Let's see, we have another question. For the Aquasuite software, does it work per scan point, such as level or flow? Or is it just an application that is installed and gets information from a normal PC or plant controller? Christophe, can you provide an answer on this question?
Is that a question how we retrieve data?
I think so, yeah.
Yeah, it doesn't really matter, I think, where we got the information from. Normally, we connect to the client's data hub. So not us, but the client will gather the data, so third party, and they provide it to us through whatever link. It doesn't matter whether it's an API or an event hub, or it doesn't matter which type of coupling. The moment we can couple to the data to where it's coming from, then it's okay with us. There's no requirement for a specific data location or whatever. The moment we can link to it, communicate with that other system, then it's okay.
Thanks, Christophe. Tom, I have a question for you. It says, thanks for your excellent presentation. I would like to hear about an example of a project that gives benefits.
We're not able to publicly share details on case studies yet, though I could take that one offline. We are deploying Aquasuite sewer in the UK for 3 water utilities, one of which actually was publicised just recently. We won an innovation challenge with Wessex Water in the UK. So we're deploying Aquasuite onto, and it tends to be on cities where there are particularly challenges around collecting wastewater. So we're going to deploy on the Wessex project into the city of Bath, for which those of you who are familiar with the UK is one of our UNESCO heritage sites. So it's particularly challenging. You can't build stuff there. It's quite a difficult area to work in. And we're going to deploy Aquasuite sewer on that network to try and predict overflows, or to predict overflows and to detect problems before they become blockages and so on. But we're happy to follow up further via email with further information on case studies and so on.
Thanks, Tom. I think we have time for 2 more questions, maybe. Next one that I have here is, can the Aquasuite software work with any hardware? If so, what are the hardware accompanies the installation?
So yeah, we can work with any hardware. Like Christophe said earlier, we just need good data. The good thing that we see is if we work with companies who can supply good hardware and good installation. So it's not just a case of you needing good hardware. When you're measuring levels in sewers, you do need a good installation as well. So it's the combination of the two together. And that's why we've seen profitable relationships with good sensor manufacturers. But also, we recognise that there's a lot of existing equipment out there, and we can retrofit Aquasuite Sewer onto existing sensors, usually fairly simply.
All right, thank you, Tom. So I'll just pick one more question for you, Christoph. How do you handle the corrosion issues on the instrumentation installed in the sewer and expected lifespan of the instruments? Good question.
Aquasuite doesn't do the maintenance, obviously, but what we do is check instruments with each other. So the model reads instruments from a catchment. So I say that you have 5 or 10 instruments in one catchment, and one is drifting off, one of the sensors, because of corrosion, for example. We would detect it as one instrument failing to provide the right signals. So we cannot see whether it's corrosion or something else, electronic failure. But we compare instruments with each other in the same catchments, and then you can see that one of the instruments is off. And then that gives you a warning to see to say that there's an anomaly for that particular instrument.
Thanks, Christoph. Well, it's time, I guess. Thanks everyone for all your questions. We haven't been able to answer all your questions, but like Tom said, we will get back to you about it by email. And well, I'll just hand it over to you, Tom.
Yeah, thank you everybody for listening. We've had some great questions. Hopefully you found the webinar informative. Both mine and Christoph's contact details are on the screen, so please feel free to get in touch. Or please feel free to visit our website or drop a general inquiry to our email address. Thank you all for listening. Hope you will join us for our next webinar in a few weeks' time. Thank you.